All right, hello folks. It is time for us to look at the 4-3 worksheet with side, angle, side, and side, side, side congruence. Number 12 says, Zhang says triangle ABC is congruent to triangle ADC. Explain the error in Zhang's work. So he says AD is congruent to CD, which obviously is true based on the diagram. AC is congruent to itself, totally fine. And DCA is congruent to BCA. So DCA is right here, BCA is right here. Those are also congruent. Therefore, triangle ABC is congruent to triangle ADC by side, angle, side. However, we have side, angle, side of triangle ADC, but we don't have side, angle, side triangle ABC. His first two sides are from the same triangle, and we need two sides to be from different triangles. We need corresponding sides from the two triangles we want to show are congruent in order for them to be proven congruent. So his first two sides, let me move this up. His first two sides are from the same triangle. But they're supposed to be from different ones. Different ones. That's all. Number 14 is triangle JKL congruent to triangle MNL. We see that we have a leg congruent to a leg, or a side congruent to a side, another side congruent to another side, and of course we have vertical angles here, and we know vertical angles are congruent. So we are showing side, angle, side congruence. So yes, because vertical angles make the triangles congruent. Make the triangles congruent by side, angle, side. Number 15. Why is triangle ABC congruent to triangle GHJ? So this one goes in two steps. We're going to compare both of them to triangle DEF. And I can see that triangle ABC is congruent to triangle DEF by side, side, side. So that's our first part. Triangle ABC is congruent to triangle DEF by side, side, side. Also, triangle DEF is congruent to triangle GHJ by side, angle, side. So that's our next part. Triangle DEF is congruent to triangle GHJ by, sorry, that's a J. Hold on, we're going to try these two words over again. Still getting the hang of doing these videos. GHJ by side, angle, side. I actually am making these videos all in the summer before school starts so that I can get them done, but also so I can get used to writing on the iPad because it's something that's really new to me and it's not very easy for me. So finally, since both of these triangles happen to be congruent to triangle DEF, they must be congruent to each other by substitution. So triangle ABC is congruent to triangle GHJ by substitution. And that substitution in sometimes is also known as the transitive property, where we go from one thing to a second thing the second thing to a third thing, which makes it so we can connect the first thing to the third thing. The specific kind of substitution that we're using there is called the transitive property. So if you ever see that, that's another name for it. All right. Then number 17, a proof. Prove triangle ACE is an isosceles triangle. Let's go ahead and make our T-chart. So we've got our statements and reasons. And firstly, we'll use our given information, which is in the diagram right now. So the diagram tells us lots of information. We're going to start by using information about these two triangles on the outside. So those are the ones I want to look at first. So I'm going to say that I know that AB is congruent to BC, and I know that CD is congruent to DE, because that's what's going to help me here. And I also know that angle ABC is congruent to angle CDE. All right? And actually, I should probably make these congruencies the opposite of what I have them. I should make them congruent to their corresponding sides in the second triangle. So AB should actually be congruent to DE because it's in the second triangle. And CD should actually be congruent to BC because it's in the first triangle. There we go. So now those are all given from the diagram. And because of those things, they're already marked in the diagram, I can state that triangle ABC is congruent to triangle CDE by side angle side. So triangle ABC is congruent to triangle CDE by side angle side. Then I know that AC is going to have to be congruent to CE, right? Because this triangle is congruent to this triangle, I know that this side is congruent to this side by CPCTC. Corresponding parts of congruent triangles have to be congruent. So my next step is to say that AC is congruent to CE by CPCTC. Corresponding parts of congruent triangles are congruent. All right, and then 4, once I know that these two are congruent to one another, I can say, because I'm proving that this triangle is isosceles, I can say that triangle ACE is isosceles. So triangle ACE is isosceles. And why? Well, it's because now I've shown that two sides of my triangle are congruent. And if two sides of a triangle are congruent, then by the definition of an isosceles triangle, it's isosceles. And there you have it. Not too bad there. Number 19, what additional information is needed to show that these two triangles are congruent by side, side, side? Well, if they're congruent by side, 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 I need to know that all three sides of triangle PQR are congruent to all three sides of TUS. So I need 2 more pieces of information. I need to know for sure that the missing side of PR is equal to 6 and that the missing side of TU is equal to 8. Because that would show me that all 3 sides of the triangle on the left are congruent to all 3 sides of the triangle on the right. Number 20, what additional information is needed to show that these two triangles are congruent? Well, I have one side and I have the angle over here. And I have one side and the angle over here. So I actually need quite a bit of information here because I need to either be able to use side, 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 in which case I would need these two sides and these two sides, or side, angle, side, in which case, because I know this angle and this angle, I would still need to know this side and this side, this side and this side. So no matter what, I'm going to need the other two sides of my triangle to show that these are congruent triangles. So must know that AB is congruent to DE, and must know both of these. AC is congruent to DF. If I know both of those, I can either use side, side, side to show that the triangles are congruent, or I can use side, angle, side to show that those triangles are congruent. Next page is triangle RSV congruent to triangle UTV, and explain. So let's see what we've got here. What I see first of all is I see that there are congruent angles right here. And if I know there are congruent base angles, then by the isosceles triangle theorem, I know that there are congruent side lengths right there. And now I look and I see that on these two triangles, they have each of their sides marked congruent to the corresponding side, so they must be congruent. So let's explain that. We'll say yes, because SV is congruent to TV. SV is congruent to TV by the isosceles triangle theorem. The isosceles triangle theorem. And so the two outside triangles are congruent by side, side, side. So the two outside triangles are congruent by side, side, side. By the way, there's no hard and fast rule for when I use the word congruent or the word triangle or the symbol congruent, the symbol for triangle. It's really whatever fits in the space. There's not a rule about it. Number 22 is triangle PQR congruent to triangle PSR, and explain what we've got. Oops, I didn't know I could do that. How do I change that? There we go. Okay. So we need to notice that we have a side and an angle, a side and an angle. And if we remember, this middle side, since it's part of both triangles, can be considered to be congruent to itself. And since that side is congruent to itself, we've got side, angle, side, side, angle, side congruence there. So we can say yes, because PR is congruent to PR by the reflexive property. The reflexive property. And that means the triangles are congruent by side, angle, side. And the triangles are congruent by side, angle, side. Number 25, Justice and Leah both made a triangular scarf. Do the scarves have the same size and shape? What do you notice about the information that is given? That's fun. I know two people named Justice and Leah who are friends in real life. So the scarves have some information given. We know that this scarf has a 36-inch long side and a 26-inch short side. This scarf has a 36-inch long side and a 26-inch short side. But they don't have all the same, right? I don't know this side and I don't know this side. So I know two sides of each scarf. I don't know any angles about each scarf. And with information that's just side, side, I don't have enough information to use either of my triangle congruence theorems to state for sure that these two triangles must be congruent. I would either need the third side or I would need to know the included angle, and I don't know either one of those things. So we can't tell if they have the same size and shape. We can't tell if they have the same size and shape. There's not enough information. There is not enough information. You would need to know the third side or the included angle to say for sure. You would need to know the third side or the included angle to say for sure. And there we go. Number 26, which sets of congruent parts are sufficient to conclude that these two triangles are congruent? Well, let's do some writing and erasing. So if we know that FG is congruent to JK, like that, we know GH is congruent to KL, and we know FH is congruent to JL. That gives us side, side, side congruence, so we know that those are congruent. Next, FG is congruent to JK, like that. FH is congruent to JL. And angle FHG is congruent to angle JLK. Well, in that case, we don't have enough information. We have side, side, angle. That's not the included angle. So it's not enough information. All right, it's not side, angle, side. Next, we have GH is congruent to KL. We have FG is congruent to JK. And we have angle FGH is congruent to angle JKL. And there we can see that we have two sides and the included angle. So by side, angle, side, we know that those are congruent. And finally, we have JH is congruent to KL. We have FH is congruent to JL. And we have angle FHG is congruent to angle JLK. And we have side, angle, side, side, angle, side congruence. So those show congruence. So it should go yes, no, yes, yes. Number 27, consider triangle DEF and triangle PQR. Which additional piece of information would you allow to conclude that these triangles are congruent? And it looks like they're all angles. So if we wanted to use side, angle, side, we would need to know that the angles which are included are the angles which are congruent. So that would be F and R, which is option D. All right, hopefully this helped you out. If you have any questions, please let me know. Thanks so much and have a wonderful day.